Good afternoon, everyone. So I'm going to be talking about, when this works, the strategic and operational implications of disruptive technology, just like that. In that, I'm going to be looking at a couple of different technologies and exploring how they're used. So disruption is basically the buzzword of the modern military thinker. It's been used very frequently, with this year's Air Power Conference being focused on that particular topic. And as you can see, technology doesn't want to work for me once I've disrupted it. So my aim in this presentation is to generate some discussion about these four technologies, being cyber, space, uninhabited aerial systems, and artificial intelligence, and examine their implications for the RAAF, but this can be expanded to the ADF as a whole. This discussion is particularly important from my perspective within junior officers, because we are who will be taking over in the future, and we need to have an understanding of the environment we'll be working in. So a bit of background, obviously the RAAF is transitioning to a 5th generation Air Force under Plan Jericho, and this focuses on integration, workforce, and capability sustainment. All three of these areas are ripe for disruption by disruptive technologies. I've already had one question on how workforce can be disrupted by artificial intelligence. There are some current trends happening within air power. These are a decline in Western air superiority. In the Middle East, we could assume that our aircraft can operate without being attacked, but now we're seeing a transition back to this isn't the case with the rise of China and Russian aircraft. Additionally, the ranges of engagements are increasing. F-35 brings in beyond visual range conflicts, and this forces a greater reliance on sensors and digital systems to identify targets. Two key aircraft in this are the Growler and the Triton, and this introduces RAAF into airborne electronic warfare and high-altitude, long-endurance surveillance, respectively. So cyber is the first point. There are four key characteristics, I'd say, which is its pervasive, scalable, flexible, and kinetic/non-kinetic effects. So by pervasive, I'm meaning that it can affect everywhere. There is no place on the globe that cannot be affected by cyber. Each of you has a phone that can be affected by cyber. We're all walking around with multiple computers on us, and these are all ripe for disruption. Scalable refers to cyber's ability to range from tactical effects all the way up to grand strategic. It affects all the different levels within conflict. This leads on to flexible, which refers to its ability to assess different domains across the entire spectrum, to operate offensively and defensively, and to be used independently as its own strike or capability, or in joint with other domains. So one example with the kinetic effect, or kinetic being physical damage, and then non-kinetic being like digital disruption and misinformation. One example with the kinetic effect is the 2007 Stuxnet virus, which disabled and damaged Iranian centrifuges. Kinetic and non-kinetic effects are a major thing that cyber can do, because they can access power grids, shut down traffic lights, and this can cause a major disruption not just within the military sphere, but also within the civil sphere. So the impacts of this, really this means the way we fight wars is going to change dramatically in the future. Just as air power was said to be the key to winning the land and sea battles in the 20th century, cyber is now the key to winning the air, land and sea battles today. To be able to do this, we need to develop our own capability and not just be reliant on allied forces for it. That is happening right now within Air Force, Army and Navy, but it needs to be accelerated dramatically in order to keep pace with the US, China and Russia, because we are quite literally in the forefront of the next area of operations. So to do this, we need to develop joint doctrine that integrates cyber not just into the air campaign, but also within the air, sea, land battles connectively as four joint ones in one system, not just cyber with air, then cyber with land as two separate systems. On top of that, we can look at how cyber is utilised in a strategic effect, operational and tactical. There may be scope for a cyber version of a JTAC to be attached to infantry units to provide tactical cyber support within the future. And with that, cyber may be subordinate or currently subordinate to air power campaigns, but in the future, it may reverse with air power being subordinate to cyber campaigns, in that the use of air power will enable a cyber campaign to go ahead and achieve your strategic objectives. On to space. Obviously, Gallum's already covered off on a lot of this, so I'll keep this relatively quick. Similar to cyber, space can access any part of the globe, but differently, cyber accesses it in a space accesses this physically rather than digitally. And this is used for intelligence, surveillance, reconnaissance, for command and control, and for navigation, all key areas for managing military forces worldwide. And this leads on to the predictability and vulnerability of satellites. They're in set orbits. Yes, they can be adjusted and put into different orbits, but once it's in an orbit, you know where it will be at a given time. And this is vulnerable to, as Oscar Gallum said, anti-satellite systems, which aren't limited to ballistic systems. Now, you mentioned the risks of high-velocity impacts, but satellites are also very vulnerable to cyber and to directed energy weapons, which we may see in the future. The United States Space Force was mentioned earlier, and that represents a risk of space being weaponized, which until now has been limited by various treaties, which have said space can be militarized, such as the use of surveillance satellites, but can't place weapons or armed forces. The announcement of the United States Space Force raises that prospect as a real reality that we may need to face and deal with. And the Woomera Treaty does address this, but it's still being developed, so it's something that will be very closely monitored. There's also CubeSats at the top, and then new launch systems that lower the cost of access into space, meaning nations such as Australia, which couldn't previously field their own space capability, are now able to do that very easily. So what does this mean? Our heavy reliance on space systems means we need to find ways to ensure these against damage, and if they are damaged, to find ways to utilise the system without it going directly backwards. So we need to develop an indigenous capability, which means developing a way for Australia to access space without being reliant solely on our alliances and international relations with other nations. And this is particularly pertinent with presidents such as Donald Trump, who are very unpredictable. If we were to lose US connections, our access to space would significantly decline. And to counter this, Australia needs to invest in developing its own systems. That doesn't mean that we need to completely replace our reliance on United States systems, but we need to supplement it with our own. And as part of this, we also need to look at graceful degradation and redundancy. We need to assume that our space systems will be damaged and possibly destroyed. How do we operate and set up systems that are able to operate when we lose one satellite? And how do we create a system that can hinder the enemy and benefit ourselves when it's damaged? So we need to explore these options to create systems that will not fail upon damage. Uninhabited aerial systems. So we've already seen a lot of these, particularly in the Middle East with Predators, the Triton, which we've got now, all that sort of stuff. The main advantages of uninhabited aerial systems are range and endurance. So this means longer time on station, meaning it's limited by the airframes with its fuel capacity and inspections rather than on aircrew requirements. This allows for better responsive to time-sensitive targets and to missions of opportunity, meaning we can better exploit the changing battle space rather than trying to schedule things to work with human crews. We can just put a platform up there and wait. So there are various concepts of how to use drones, one of which is swarming. So this could be seen in two different ways. There's interconnected and self-sufficient. So interconnected, we're looking at a group of drones that are connected to each other and constantly talk to each other. This offers the benefits of being more adaptable, and you can update the missions partway through. Self-sufficient is different. It's looking at self-contained drones that aren't connected to other drones. This is relevant because of the risks of cyber. In the interconnected concept, if one drone is infected, the entire network is infected. But in this case, one drone being compromised does not compromise all the other drones. On the flip side of that, though, it means you can only set one mission and you have to wait for it to return before you can set another. You also have a mothership concept of operations. This is probably one that will be used very soon in the near future. It's where you have a drone controlled by an in-situ commander. And there are concepts of this where drones will be controlled by F-35 pilots to develop in-situ responsiveness. So this increases the responsiveness of drones and gives a better utilization in the battlefield. And finally, there's launch and forget, which relatively self-explanatory. You give the drone a mission, drone goes and does it, it comes back, you didn't need to put any input in. Importantly, with these three concepts, you can use them interchangeably and together. They're not mutually exclusive. Just because you choose one does not mean that you're restricted to that. And with this comes the varied sizes and complexities of drones. We have the enormous Tritons, which are capable of doing long-range missions, as well as smaller Black Hornets that we can use on battlefields. So this generates a variety of options for Australia in the future about what drones we can buy and what options we have available to us and how we can utilise these systems. The flip side of this is, because there are various low-tech options, groups such as Terra Networks have access to this and can use these to asymmetrically damage our capability. They can send in a small drone that you can buy commercially for $100, strapped with some explosives, and that can damage an entire F-35. So these are things that we need to consider about how we can access drones, but how also anywhere from a nation to just an individual actor can access this technology. So as I've said, the major advantages are the range and endurance within drones, and this leads to enhanced persistence, greater time on target, and increased on-task responsiveness. Drones also address one of the major limitations on modern air power that's provided by having to have crewed platforms. By having drones, you can reduce the requirement for fleet sizes and crews because you don't need to recycle them every 8 hours, and you don't need to try and work out the math and say, well, if we've got 2 hours to get to this location, they have 4 hours on target, 2 hours back. We don't need to be sending up crews every 4 hours. You can send them up every 50 hours. And finally, there is artificial intelligence. So there are 3 areas that I wanted to focus on here. Autonomy and agency, is it a driver or a supporter, and human in the loop. So by autonomy, I'm looking at the ability for something to do work without input. And by agency, I'm looking at how can a program choose to do the work itself? What work does it choose to do? These are 2 very important areas within artificial intelligence because it determines the level of trust we give to the artificial intelligence. Everyone's seen Terminator, where the artificial intelligence chooses what it does itself, and this can provide a very terrifying thought when we have rogue systems that we don't necessarily fully understand and can operate at a faster pace than us. And this leads into if AI is a driver or a supporter. Should we have AI merely supporting the pilot or the commander in the battlefield, or should the AI be driving the aircraft or driving the battle or even the entire war? And these are important questions to start to discuss now, particularly within the junior level, to develop an understanding of where this technology can go. Finally, human in the loop. Do we need one? If so, where? And this is an evolving question. Right now, I'm sure the answer would 100% be, yes, we need a human in the loop, and yes, we need them to monitor what an AI does. But as we progress into the future and decide the direction of AI, we need to look at where will the human be and how will they be in there. So this leads to decision superiority and faster, more accurate analytics and management. I've got an obligatory picture of the OODA loop up there. AI will be able to do this considerably faster than any of us can. And coming back to autonomy versus agency, in terms of doing this OODA loop, AI don't necessarily have to be the executor either. They can do the entire OODA loop, come up with 3 options and say, here's what I've decided are the best options, and then the human can decide which option they want to pursue. An important note on artificial intelligence is it is not an end-state technology. Once you have it, that is not the end. You don't have it like that forever. It will continue to evolve and adapt. It will continue to enable all these other technologies I've already mentioned. So implications for the RAAF and by extension the ADF. These 4 technologies would be relatively easy to work with if they were developing and maturing separately, but they're not. They're all coming into fruition right now together. And this presents a very difficult challenge of how to integrate these technologies together with our current systems and how to project a direction into the future. And this is why it is important to get junior leaders aware of these technologies and aware of the directions they can go now before you're getting them as majors and colonels and say, hey, here's some stuff that you need to know. The heavier reliance on space and cyber, that's a critical centre of mass that enemies can exploit. We need to be very cognizant of this vulnerability, because these aren't things that we can hide away and prevent from being attacked. They will be attacked and they will be damaged. So we need to think of ways that we can limit how the damage affects us, and if there's any ways to make it affect the enemy more than it affects us. Finally, there will be significant ethical and legal challenges. Within drones, we can see what constitutes a valid legal target. Within AI, how much, if AI decides to do this, what is the ethical precedent for that? Do we apply the same ethical constraints to AI as we apply to other people? And within cyber, what constitutes an act of war? These are just some examples of the challenges that we will face. Obviously, I don't know all of them. So in conclusion, to become fifth generation Air Force and fifth generation ADF per se, we will require imaginative and innovative solutions going forward. And these will come not just from the senior leadership, but from the junior leadership, all the way down to the soldier on the front line. We need to get everyone involved in this process. Future combat will be defined by an increasing reliance on and vulnerability in cyber. Everything will be underpinned by this information age. Nothing will be safe unless we can secure our cyber systems. Space will become more contested and more militarized. We need to look at this and how we can defend ourselves and ensure our own access to space. And we need to look at how weapons in space will affect us. The proliferation of uninhabited aerial systems will continue due to its benefits, and these will move towards AI. AI is going to be a driver behind all of these technologies. If we fail to understand or keep up with artificial intelligence technology, we absolutely risk being left behind by other nations. We will go from being a middle power to a small power in the blink of an eye. So for all of these technologies, we need to be aware of how they're working, of where they're going, and start developing solutions. Australia must rise to the challenge of the changing character of war if it is continued to be able to deter, deny and defeat threats and attacks on its borders and interests. Thank you.